We're going to be looking at line segments and distance today. So the first thing is to calculate the measures on line PQ to say that point M is between points P and Q means that P, Q, and M are collinear, and the length of segment PM plus the length of segment PMQ is equivalent to the length of the entire segment PQ. So we have a picture of a line here. We've got the 3 points that are collinear, P, M, and Q. M is between P and Q, as it said in the description. And the last part of that statement there says that if we add P and M together and we add M and Q together, then we end up with the length of PQ, so the length of this full segment here. One special note on the notations here, if you've got line segment PQ with the segment notation on top of it, that refers to the segment itself, whereas if you just say PQ and you leave off the line on the top, that's actually referring to the length of the segment, or the distance between points P and Q. So moving up a little bit here. Okay, so on line AB, it says that AB is equal to BC, so this is the length of AB and the length of BC. They are equal to each other and they're both 3 centimeters. So with that, we can say that the segments are what we call congruent segments because they have equal measures. So another way to say that, we have a special symbol for congruence. That's this lovely little equal sign with a little wave on top of it. So this says line segment AB is congruent to line segment BC. To indicate that congruence on a figure, this is pretty standard notation, we put a little slash on them. So on this one, I see I've got line AC, that includes line segment AC, and line segment AB, and line segment BC. And so the description said that line segment AB and line segment BC were congruent. So we've got a slash on those to show that they are congruent. They also told us that each of those was 3 centimeters. So I could say 3 centimeters for each of those as well. Truthfully though, I wouldn't need to label both of them. I could just label one of them, and then the slash marks would indicate that they are in fact still congruent. Okay, so now we're on to an example now. We've got our basics down. And our first example says that we have this line MP, and point A is between points M and P. And they want us to calculate the length of MP by adding MA and AP. So I'm going to write that down first. The length of MP is equal to the length of MA plus the length of AP. So on my next line here, I don't know what MP is, so I'm going to leave that as just MP. But then I can fill in the length of MA using my diagram up here. It says that that is 2 inches. And I can fill in the length of AP. Again, using the diagram there, it says that that one is 3 inches. And so if I want to find the length of MP, I would simply add those two together. 2 inches and 3 inches are like measures, so I can add those, and I would get 5 inches. Okay, next up, I've got a similar kind of problem here, except this time we're introducing a little bit of a variable in there. So they want us to find both x and the measure of the length of AC. So here I've got a picture. I see that point B is between point A and point C. The length of the entire segment, so AC, well, let's start off with this. I know from my statements above that AC is equal to AB plus BC. Now I can fill in everything that I know. So I know from A to C, it is 2x plus 8. So I'd fill that in. And from A to B, according to my picture, is 3x. And from B to C, the length is x. So now I end up with this algebraic equation that we could solve for x. It's an algebraic equation with only a single variable in it. That variable occurs 3 times right now, but we know how to deal with that because we've already made it through algebra. So 3x plus x is 4x. My next step would be to get the x's together on one side of the equation. So I would subtract 2x from both sides. And then I would divide both sides by 2. So I would end up with x is 4. And that's the first part of the information that they asked me to find, but they also want me to find the length of AC. So once again, the length of AC from my diagram is 2x plus 8. From the work that I did over here on the left, I found that the value of x is 4. So my length of AC is going to be 2 times 4 plus 8. And the pen is going to be very laggy now. Okay, so 2 times 4 plus 8. And then, of course, it's just a matter of performing that arithmetic there. 2 times 4 is 8, and 8 plus 8 is 16. So my length of AC is 16. Go back and read the instructions just to be sure I've answered everything that they asked me to. They asked me to find x, and I did. They asked me to find the length of AC, and I did. Okay, so next up, we've got some guided practice problems here. So I want you to start off with trying to do numbers 1, 2, and 3. You're going to pause the video here and do those 3 problems, and then come back and see how you did. Okay, welcome back. Let's see how you did here. So on number 1, the length of AB turned out to be 2.25 meters. The value of x was 2.25, which, I'm sorry, the x I introduced into the problem there. Okay, for number 2, the length of the AC was 8.2 centimeters. And on number 3, there were 2 answers you needed. You needed the value of x, which was 24, but you also needed the length of QT. And so QT is 120. If you missed any of those, of course, you should stop right here and go back and try to figure out why you missed them. If you got them all correct, then you should pause the video again and now try 4, 5, and 6. Welcome back. Let's see how you did. So on number 4, the x value is 12, and that made the value of the length of QT 96. Number 5, the x value was 14. The length of QT was 84. And on number 6, the x value was 3, and the length of QT, therefore, was 27. Okay, now we have a couple of true-false questions here. So, that's some weird writing there. That's probably going to recur because it just does. Okay, so true-false here. So this first one says, given the figure below, segment AD, remember this symbol means congruent, is congruent to segment BC. Now to be congruent, they have to have the same length. So this would mean that AD has to be equal to BC. Otherwise, it's false. Okay, so looking at the figure here, AD is this one up here, and BC is this one down here, and they are both labeled with 12 inches. So since they do have the same measurement, and this is saying that the 2 line segments are congruent, we would say that this one is true. So keeping that information in mind, I want you to now look at the next one that's on the screen here, this triangle, and it says the line segment AB is congruent to line segment BC. So look at the picture there and see what you think. Go ahead and pause the video if you need a moment. Now this one is false. All right, there are two congruent line segments on here. Line segment AB and line segment AC are congruent, even though the measurements that they have listed on there look very different. They're still congruent. So truthfully, we could probably find the value of x here, because we could say since those two line segments are congruent, then that would mean that 2x plus 5 has to equal 3x minus 1. And so you could solve that for x if you needed to. All right, next concept. Next up is a distance between 2 points on a number line. So we're going to be working with some number lines here. Let's see. And it's very laggy. Okay, so we have a number line here, and we've got 2 points called P and Q. And then the variables that we have listed underneath, the lowercase x and the lowercase y, those just represent some numbers, whatever the numbers happen to be on the number line. So if I wanted to find the distance from P to Q, or the length of line segment PQ, I would find that by taking the absolute value of one number on the number line minus the other number on the number line. Now, since we're doing this in absolute value, you can actually do that in either order. So we could say x minus y, or we could say y minus x. The effect of the absolute value is that it's going to make that value positive, whatever you happen to get on the inside there. Since it is talking about a distance between 2 points, that does need to be positive. So we have an example here. So for our example, we've got point A and point B, and we are supposed to find the length of line segment AB. So using the formula that we had before that they just gave us, I would take the absolute value, and then I would just subtract the numbers that are on the number line associated with those points. So -3 minus 2. And now I have to calculate that, of course. So when you're calculating that absolute value, you have to work inside the absolute value bars first. So -3 minus 2. They function kind of like grouping symbols that way. Then once you've done that, you can take the absolute value. So the absolute value of -5 says how far is the number -5 from 0 on the number line? And the answer to that, of course, is 5. So, of course, on a number line, this is kind of trivial, particularly when the points are really nice and neat there. We could just count. So we could say 1, 2, 3, 4, 5. But if they were really far apart, this method might be easier. Or perhaps if one of the points was given as a variable and you had to find out where that was, this formula would be very helpful. Okay, so we have some more guided practice here. Just 4 more questions. So you're going to pause the video again, work these 4 questions, and then come back and see how you did. Okay, welcome back. So the distance from C to D is 3. The distance from A to D is 6. The distance from B to F is 6. And the distance from E to A is 15/2, or 7.5. Those are both equivalent. All right, it's now time to work on your practice. You will find in Schoology a Google form. So you're going to work on that Google form now to perfect your skills.